So why would we use Python? Because there's many languages that you can use for data analysis. Some of these languages include MATLAB, R, C++, and of course Python, and they can all be used for data analysis, matrix manipulation, and plotting, and they have all types of built-in calculus functions and statistical functions. And there's numerous developers that have created libraries and functions in all of these softwares to make matrix and statistics and other calculations easy. MATLAB in particular is the language I learned on, and so it really excels at matrix manipulation, plotting, and calculations. However, MATLAB can be expensive for non-students and companies, and both Python and R do have libraries that were built in to emulate some of those matrix and plotting functions in MATLAB. The big advantage of both Python and R is that these are both free open source tools, and therefore many universities and companies have adopted using these tools. And Python is a strong general purpose programming language, and the data manipulation tasks have improved greatly in recent years in Python. A lot of the libraries were added to emulate the functionality of MATLAB. So Python has been successful. I mean, there's many reasons why, but one of them is because of the ease of integration of C, C++, and FORTRAN. And often in companies, they would build prototypes in language such as MATLAB or R, and then for production use, they would transfer it to C, C++, or Java. So it kind of was a lot of work doing that. And people are now finding that Python is not only suitable for research, but also production systems. So that kind of saves them time because they can build their R&D tools in Python and then implement it in production. One of the only drawbacks of Python is that it can run a little more slowly than code written in a language such as C++ or Java. But often that's not the case, and usually the trade-off is that Python is a little faster, actually could be a lot faster in the initial development and programming time. So often companies like that trade-off. They'd rather use something that's easier to get a prototype up and running and is a little slower than take something that to use a language that takes a lot longer to develop. So some of the libraries that we'll be discussing over and over again throughout this bootcamp is NumPy, Skypy, Pandas, and Matplotlib. NumPy is the foundational package for scientific computing in Python. It has efficient methods for making arrays, mathematical functions, linear algebra functions, and it also includes tools for integrating C, C++, and FORTRAN. Skypy has a lot of functionality such as linear algebra. It has differential equation solvers, signal processing, and probability distributions, as well as many other types of functionality. Pandas is one that we'll be using quite frequently throughout this boot camp, and one of the best functions, in my opinion, is that it allows data frame objects which emulate matrices in a software program such as MATLAB. Data frames make it easy to reshape, slice, and dice data, which is extremely important as a data scientist. Matplotlib was a library created to emulate MATLAB plotting because MATLAB always had extremely good plotting functionality, and the Python plots look identical to the MATLAB plots. So Matplotlib is one of the most popular libraries for producing all types of histograms, scatter plots, all types of 2D plots and some 3D plots as well.